6 galaxies just broke the universe, not metaphorically, not as clickbait. 6 massive, fully formed galaxies were found by the James Webb Space Telescope in a region of space so ancient that nothing that large should exist there. They are older than our physics says is possible, and right now, thousands of scientists around the world are scrambling to figure out what went wrong. Not with the telescope, but with everything we thought we knew about how the cosmos was built. To understand why this discovery sent shockwaves through astrophysics, you need to picture what the early universe was supposed to look like. Imagine the Big Bang not as an explosion, but as the birth of time itself. Space expanding outward, carrying energy and matter with it, like a wave carries foam. In those first few 100 million years, the universe was a dark, featureless fog. No stars, no galaxies, just clouds of hydrogen gas slowly, painfully slowly, pulling together under gravity. The first stars, clumsy, enormous things, wouldn't ignite for another 200 million years. And fully formed galaxies? The kind with billions of organized stars swirling in elegant spirals? Those weren't supposed to arrive for at least 1 billion years, maybe longer. Think of it this way. If the universe were a human life, those first few 100 million years would be the first week after birth. You wouldn't expect a newborn to walk, talk, or run a marathon. You'd expect a blob, formless, raw potential. That's what cosmologists expected to see when JWST pointed its golden mirror at the oldest light in existence. Instead, it found marathon runners. The 6 galaxies, catalogued during the CEERS survey, short for Cosmic Evolution Early Release Science, appeared in JWST's infrared images as bright red dots. Red, because their light has been stretched by the expansion of space for over 13 billion years. When researchers at Penn State and the University of Texas ran the numbers, the results were staggering. These weren't small, wispy proto-galaxies. They contained tens of billions of stars. One of them appeared to hold as many stars as the modern Milky Way. At an age when the universe was barely 300 million years old. Joel Leja, the Penn State astronomer who led the analysis, described the moment they processed the data as something close to panic. The team checked the instruments. They reran the calibrations. They questioned whether the redshift measurements, the cosmic ruler that tells us how far away and how old something is, were somehow wrong. But the data held. Every check confirmed the same impossible answer. These galaxies were far too massive, far too mature, and far too early. The problem is not just that the galaxies exist. It is what their existence demands of the timeline. To build a galaxy with 50 billion stars in 300 million years, you would need stars forming at a rate roughly 100 times faster than anything our models allow. Current theory says galaxies grow the way cities grow, slowly, through mergers, acquisitions, one neighborhood at a time, over billions of years. What JWST found is the equivalent of discovering a modern skyscraper standing in the middle of the Stone Age. The building is real. The timeline makes no sense. And the problem gets worse the deeper you look. JWST's near-infrared camera, NIRCam, can see light that has been traveling for more than 13 billion years. That means it's essentially a time machine, showing us what the universe looked like when it was a toddler. In every direction the telescope points, it keeps finding more of these anomalies, not just the original 6. Dozens of candidate galaxies have now been flagged across multiple surveys, each one too bright, too heavy, too evolved for the age of the universe at the time their light was emitted. This isn't a single strange data point. It is a pattern, and patterns demand explanations. So what went wrong? There are a few possibilities, and none of them are comfortable. The first is the simplest. Maybe the measurements are off. Redshift estimates rely on the color of light, and at these extreme distances, Dust and other factors could skew the readings. Some galaxies initially flagged as impossibly old were later found to be closer and younger than first thought. But not all of them. The ones that have been confirmed spectroscopically, meaning scientists split their light into a precise spectrum and measured exact chemical signatures, remain stubbornly ancient and stubbornly massive. The second possibility is more radical. Maybe galaxies can form much faster than we assumed. Perhaps in the dense, hot conditions of the early universe, gas collapsed into stars with an efficiency we haven't accounted for. Instead of the slow, messy process our simulations model, where gas cools gradually, forms clumps, and eventually ignites, maybe some mechanism we don't understand compressed matter into stars almost instantly. Some theorists have proposed that the early universe's dark matter halos, the invisible scaffolding around which galaxies are built, were denser and more concentrated than current models predict. Denser halos would mean stronger gravitational pull, which would mean faster star formation, like water swirling down a wider drain. The third option is the one that makes physicists lose sleep. Maybe the problem isn't our galaxy formation models. Maybe it's the model of the universe itself. The standard model of cosmology, called lambda-CDM, is the foundation everything else rests on. It describes how the universe expands, how matter clumps, and how structures grow over time. Lambda-CDM has survived decades of testing. It predicted the cosmic microwave background radiation. It predicted the distribution of galaxy clusters across the sky. It is, by almost every measure, one of the most successful scientific models ever created. But if galaxies are routinely forming in ways lambda-CDM says they cannot, then something in the foundation may be cracked. This is not the first time JWST has caused trouble. Since it began science operations in mid-2022, the telescope has delivered one unsettling result after another. Stars that appeared too soon, black holes too massive for their age, chemical signatures in early galaxies that shouldn't be there yet. Each discovery on its own could be explained away as a statistical fluke or measurement error, but together, they form a drumbeat that is getting harder to ignore. Something about the early universe was fundamentally different from what our best theories predicted, and we are only now, with a telescope powerful enough to actually look, beginning to see the gap between prediction and reality. What makes this moment so extraordinary is that it is not a crisis in the traditional sense. Nobody is arguing that physics is broken. The laws of gravity still work. Light still travels at the same speed. What has broken is our story. The narrative we built about how the universe got from the chaos of the Big Bangs to the organized, galaxy-filled cosmos we inhabit. That story had a specific timeline, specific rules, specific milestones. And the universe, it turns out, did not follow the script. The next few years will be decisive. JWST has at least 15 more years of operational life, and every month brings new observations of the earliest epochs of cosmic history. Teams around the world are building new simulations, testing new models of star formation, and proposing alternative cosmological frameworks that might accommodate what the telescope is finding. Some of these new ideas will fail. Some might reshape the field entirely. But here is the part that should stay with you. For most of human history, we had no idea how the universe began. Then, over the last century, we built a story, a remarkably detailed, elegant story about the first 13 billion years. And now a single telescope, floating 1 million miles from Earth, at a point where the gravity of the Sun and Earth balance out, is quietly telling us that story was incomplete. Not wrong necessarily, but incomplete in ways we hadn't imagined. The universe was doing things in its first few 100 million years that we didn't think were possible. And the fact that we built a machine capable of catching it in the act, of seeing light that has been traveling since before our galaxy existed, might be the most extraordinary part of all. We pointed a mirror at the beginning of time, and the beginning looked back at us with a face we didn't recognize.